Good morning again. We're on 1.4. We're writing equations and inequalities. So the video before we translated verb phrases into expressions. Now we're going to translate verbal sentences into equations or inequalities. An equation is a mathematical sentence that connects two expressions with an equal sign. So an expression, 2x minus 4, that's an expression, and 7 divided by 2. Okay, that's two mathematical expressions connected with an equal sign. Now the key is they must equal for it to be true in an equation. And an inequality is, again, two expressions connected with a less than sign, a greater than sign, or sorry, less than or equal to. So less than or equal to, greater than, or greater than or equal to. Okay? So this is less than. Now, if you're wondering, well, didn't the last video you say less than also could be minus? That is true. Actually, the book does have this, so equal. Okay, we'll go to how the video talks about it. And the book says equal to, less than or equal to, greater than, or greater than or equal to. Okay? Or equal to. Okay. So less than or equal to, greater than or equal to. Okay. This means also this could be the same as or is sometimes. This could be fewer than. So this is the verbal phrases. Fewer than, at most, no more than, this is more than, and then this one is at least. Okay? Or no less than. Okay? Let's look at some key ones. Sorry. Before we look at some more. Sometimes two inequalities are combined. For example, inequalities x is greater than 4 and x is less than 9. Now when it's combined, it becomes one sentence. For example, x is greater than 4 and less than 9, which is one combined sentence, okay? This will be crucial in chapters 6 and 7, but, we will come back to inequalities later. The difference of twice a number k and 8 is 12, okay? First verbal phrase. The difference of twice a number, so difference, twice a number k, 2k, and 12, that's a minus, is, so that's equals 12, okay? So is here is equals, okay? The product of 6 and a number n is at least, which means at least, what? 24, okay? A number y is no less than 5 and y is no more than 13. Could we write this as one phrase? Yeah. So we can do 13 is greater than or equal to y is greater than or equal to 5. Or you could say 5 is less than or equal to y, which is less than or equal to 13. Okay? Okay. Now, you don't have to do this middle thing, but it helps to organize your thoughts. Okay, let's go to the next example. Now, okay, before we go to the example, we have some definitions. So, key definitions. The solution of an equation or inequality is the number that you plug into a variable, substitute in the variable, that makes it true, okay? So if it doesn't work, it's not a solution. Pretty straightforward. So let's look at some. So if we have the question, 8 minus 2x equals 2, and you plug in 3, 8 minus 2 times 3 equals 2, you get 8 minus 6, and so 2 equals 2. Now is that true? Yeah. So that's the solution. So 3 is a solution, okay? Now these are all in the book. It's just kind of practicing it over again to give you some more context. Okay, but what about 4x minus 5? Well, if we can see in the book, 4x minus 5, we get 4 times 3 minus 5, does that equal 6? 12 minus 5 equals 7. 7 does not equal 6, okay? So it's not a solution, okay? Okay, and then if it's great, so for inequalities, the number has to fill it. For example, you have 2z plus 5 is greater than 12. So if we plug in 3, we get 11. So sorry, 6 plus 5 is greater than 11. I mean 12. Well, we'll see. 11 is not greater than 12. Okay, 11 is not greater than 12. So this would be, so 3 would be not a solution. Is not a solution. Okay? Is not a solution. Okay? 3 is not a solution. Well, what else might be a solution here? Yeah, well, what about 4? 4 might work. 4 plus 5, 8 plus 5 gives us 13. 13 is greater than 12. So then in this case, 4 is a solution. And actually, the key is you can solve some of these for a variable later on and get the total number solution. Using mental math, we kind of did that on the homework assignment. So basically just plugging, x plus 4 equals 10. Well, then x equals 10, right? So sometimes we can look at something, and actually the more comfortable we are with multiplication, division, addition, and subtraction, the more mental math we can do. So here, x equals 6. Now, what's the work? You subtract 4 from both sides. But the reason why we show work is not because we need it. It's because we check if we made a mistake. So sometimes when we do mental math, we might do addition when we need to do multiplication, subtraction when we need to do division, or vice versa. And the key is you have to do the right operation and respect the numbers. So sometimes some numbers that get people confused is 6s and 7s. So whenever I say this, people kind of don't take me seriously. But if you're not sure, if you ever have trouble with mental math, always go back to your multiplication tables and addition tables. It will solve a lot of your issues. And do some of those and get quicker at them, get more active. Okay, let's write a verbal phrase for this, and then we'll be done. Okay, the last time you and 3 friends went to Mountain Bike Park, so we have 4 of us, you had coupons for $10 off and paid $17 for 4 tickets. What's the regular price? So, you paid $17 for 4 tickets, but our 4 tickets, whatever price it was was minus $10, right? So then doing the math, our regular price would have been $27. Okay. Now, if this is currently America, then I'm shocked because it's pretty cheap. Okay, and then they ask, if you paid the regular price of this share equal, how much would each person pay? So then you do $27 divided by 4 people. Or, if we do work out the math, we get $6.75 per person. Per person. Okay. Okay, and that is our work. Now, there is an inequality version of this, and you can check it. It does talk about they need to average per game to be B, so they have to be greater than the last year. So anyway, you're welcome to check that out. I know this video went a little bit long, but was most of it just talking about other things. So guys, remember, just take notes. You do not need to turn these in, but this is a way for you to review key concepts in preparation for the harder material in Algebra 1. Thank you guys. Have a great day.